I've been using Kubernetes since around 2016, back in those sort of orchestration war days, where there were a whole bunch of projects vying for the winning spot. But I'm mainly from Auckland and had a bit of a stint over in Melbourne. And as Thom mentioned, currently working at Westpac as a platform engineer. We're managing and supporting quite a few on-prem clusters. It's quite a big scale, 520 nodes, 12,000 containers. And they're currently on a project to migrate to OpenShift 4, so that's what we're working on at the moment. And there you go, red hat. Yeah, and in recent times, I was actually a founding partner of Amazio, which was acquired by Mirantis in 2022, and conveniently, they're up next on the talk, so you'll hear more about them soon. But anyway, this talk here is actually about Spinkube. Spinkube is an open source project which streamlines developing, deploying web application, WebAssembly workloads in Kubernetes. It basically was released last year. It was a combination from the 4 partners, Microsoft, Reply Liquid, SUSE, and Fermion. And it just makes life really easy for deploying WebAssembly applications. But before we get into the details of the project, probably need to step back and explain a few things around the components that make up Spinkube. So first of all, WebAssembly. WebAssembly is a binary instruction format. It's essentially a compilation target for programming languages, and it was originally designed, as the name suggests, for running high-performance applications in a web browser. But the people who created it were quite smart about the idea, and they said, hey, you know, this, although it's called WebAssembly, actually has use cases outside of the browser. And this is where this idea, the concept of running WebAssembly elsewhere, has picked up pace over the years, and there's quite a big movement to make use of it. So the other side of WASM, you'll hear a lot, is WASI. Just something to point out, this is a sort of a system project, but the idea is it's the WebAssembly system interface. It really is allowing your WASM applications access to system resources. That's less important on the browser, but more important when you're running, let's say, on Kubernetes or things like that. Won't go into much more detail, but it's a short talk. But yeah, but just know it's there. One interesting thing, and this is actually from Solomon, and he tweeted this just after WASI was announced, and he said, you know, if this was around in 2008, we wouldn't have the needed to build Docker. This, to be honest, is a bit of a hype tweet, and he's even confirmed it. It's not a one-to-one match. It's not go and throw your Docker builds out the window. You know, it's still got a long way to go. So, but you know, the vision's there, I guess. So yeah, what makes WASM so awesome? The binaries are really, really small. So when you compare them to containers, they're only a little bit bigger than your x64 binaries. They're extraordinarily fast to start, so they're just, you know, the tiny little units. Not like a container, which, you know, has to rebuild its file system and start up. So, you know, a lot of these could just start up in milliseconds, and hopefully we'll demo that shortly. They're really, really well isolated because it was designed to run in a browser. So run essentially of pulling code straight down from the internet, running on your machine. It's built to deny access to anything by default. And it's extremely portable because, yeah, it's a very much as long as you've got a compliant WASI runtime, basically it'll run. So, and you can also run on any architecture, so it's the WASI runtime job to convert to whatever it needs to. So you can, you know, you can move architectures without rebuilding anything. If this all sounds familiar, yeah, I mean, it probably is. It's the latest generation of the write once, run anywhere problem. But the difference here is probably these four major facts, where it's just open standardization. So, you know, lots of companies or working groups have got together, decided this is kind of like a good standard model. And so there's not really one owner. Completely, language independent, so it should really work with anything. Totally platform independent and hardware independent, so it's a standards-driven model, and then people build the tooling for the standards. Quick slide on the language support. Most of the language now are supported or are work in progress. QR code there for Fermion, that's just to show where your language or weapon of choice is available. And I think it's an unwritten rule to have a talk at a Cloud Native without a CNCF landscape slide. So, but yeah, so I started one there, and you can see there's actually Spin down the bottom. And what's happened recently, Spinkube itself was a separate project, but earlier this year they've actually combined Spinkube and Spin, which is a developer framework, and they've donated that to the CNCF, so it's a sandbox project. So it's actually only one tile in there now. And the last thing that I touched on, but yeah, to understand, Spin is the actual developer tooling for creating WebAssembly microservices. It's definitely not the only one, but it just makes it super simple and to get started. So just a brief timeline. You can see 2015 is when they started working on WASM. It was first released in 2017. It became like the fourth standard web language in 2019. And then most recently, Spinkube was released last year, along with the WASM Preview 2, WASI Preview 2. And then this year, Spinkube has been donated to CNCF, and that's where we are today. So yeah, back to Spinkube. Now we've covered off those things. Yeah, and we'll get into what makes up Spinkube. So essentially, it's a four subsystems or four groupings. Starting with the top left there, it's a spin operator. The operator is a standard Kubernetes operator. You install it into a cluster. It looks for custom resources with spin apps and goes and does what it needs to do. There's a container shim spin. This is quite an important part where it's actually swapping out kind of your container runtimes for WASM runtimes. You've got your runtime class manager, and then finally your Spinkube plugin. But we'll go over those in a bit. So we'll start with the Spinkube plugin. This is just a common model for just creating these applications with Spin. You start there with a Spin new. That'll create you like an application template. Then you do a Spin build, which is essentially building out the app, pulling in the dependencies. You can actually run a Spin up there and test your app locally and do things. But you can also do the Spin registry push, and that what it does, it packages up your WASM binary into an actual OCI image. So it reuses the same model of images, however, they're not containers. They're images with a WASM binary inside, and then you can push it off to an OCI compliant registry, and so that model is very similar to how you work with Docker, and you can just push and pull images. Finally, you pass it over to the Spinkube scaffold, and that will actually generate your Spinkube Kubernetes objects and custom resource, and then basically you apply that to the cluster. And we'll hopefully take you through that in a demo. So yeah, the Spin operator, as mentioned before, it's sitting in the cluster and waiting for your Spin app resources. As soon as it sees them, the operator will go and transform that into deployments, pods, and services. And then this is really where the magic happens, the runtime class and the shim. And this is something that you install into the cluster, and it's a separate runtime. So when the pod starts up, you'll see that the runtime class is different, and then it won't start the container, but it will actually pull the image and start the binary inside your WASM runtime, which is quite cool. So, but it's all very much familiar with kind of the process of what you're currently doing, but under the hood, it's using WebAssembly. So yeah, so I'll quickly try do a demo. Let's hope this works. Go here and, whoops, to explain. Okay, we can see that, and that's big enough. So I'll quickly explain the setup. This is just running a K3D cluster locally, and I've installed the spin operator. You can see the pod running there. The runtime class is in there, so I can quickly show you. So the WASM spin v2 runtime class is in there. And what I've also got is just a sample project, Cloud Native 2025. It's kind of like a Hello World application, but it's written in Rust. And so what I'll do is just run a spin here. And what that's doing there, it's running a spin build, which we talked about before. So packaging up all your dependencies in Rust. And then it will actually create this WASM binary. So that binary can obviously be run in any WASM runtime as needed. But what we'll be doing here is we'll be doing the packaging into a OCI image, and then we'll be pushing it off to a registry. So right now it's packaging it up and pushing it to the registry. And very shortly, we should be able to see the size of it. It happens.
Is that similar to a statically linked binary?
No, I don't think so. No, it's basically like it's a bytecode format that it's written for a WASM runtime. Correct. Yeah, it's assembly code essentially for WASM. Yeah. It is. Yeah. Sorry. And yeah, so what here we've got is you can actually just run a Docker manifest inspect, and you can see actually the image itself here is the architecture is actually WASM. We can see the size here is about just under 2 meg, and if I did a DU, it's 1.8 meg. It's pretty small, and so we'll continue on that. So this is the next bit is the Spinkube scaffold, and what that's doing is outputting that Kubernetes object for you. You can see here the reference to the image that it created. And then we can apply that to the cluster. So all that's doing is pushing it in there. And you'll see that the pods have come up. And if I just go 3, 2. Yeah, we can see here that there's 2 pods because I created 2 replicas. If I look in here, the pods themselves are running WASM times spin v2, is the runtime class. And so whilst these are pods, they're actually little binaries running inside a WASM runtime. But to show you as well, just jump out of here, what we can do is just do a scale, let's say 10, and we can create 10 pods essentially. You can see how fast that was. That's just like total milliseconds because the image is already there. All it's doing is starting. So we can actually just go and add another 10. And it's almost, instant how that sort of runs. So it's not, you don't have to start containers. Doesn't have all that overhead. And it's just super fast. So yeah, from what I've seen, apparently Fermion, which is one of the companies behind Spin, they've actually managed to get, I think, 5,000 pods in a single node just because using WebAssembly. So they're doing some pretty crazy stuff. Yeah, so that's it running in there, and then just as simple, you can scale that back down. And we can do it back to 2, for example, and it just tidies it up. So yeah, so that's it's very much native to how Kubernetes works. It just looks like a pod. And one really cool thing that I found out recently is actually you can, if you look inside, it's sort of like, it looks like a container from a Kubernetes point of view, and you can actually define a pod with a WASM binary and a container side by side. That just works. So you can just reference that. So, yeah, so that's a quick demo. But yeah, going back to the benefits that we talked about, super small package size. That just makes the moving and building of things a lot faster. The really, really fast startup time. So you can combine this with the likes of horizontal pod autoscalers or Kita, and actually have them just dynamically scale up and down as you need to. Fully sandboxed and very, very, very portable. So, but yeah, as mentioned before, one of the biggest benefits of Spinkube itself is it's just running in Kubernetes. It looks like Kubernetes. Your processes don't have to change that much. It still uses an image registry, objects, permissions, all that sort of stuff. You can add secrets, you can add config maps and anything that you need to your pods, and it just works. Like, they didn't have to do anything, and that's one of the really cool things about it. So the latest news, I think I touched on before, is that Spins has been donated to the Cloud Native Computing Foundation, so it's a sandbox project officially now. They still haven't updated everything, but they had to do migration to a new organisation and everything. And what was announced just a couple of weeks ago is they're actually backing this new thing called WASM functions, and it's the kind of the cloud edge compute system for Akamai. So it's all sort of built using the same tech. So that's probably coming to an Akamai near you. Yeah, and that's it. Thank you very much. More information at spinkube.dev.